All right, let's kick things off with a pretty fundamental question in the world of software. How do you possibly measure something that you can't see or touch? Today, we're going to dive deep into the whole idea of software metrics.
I mean, really think about that for a second. If you're building a house, you've got square footage. You're building a car, you can literally count the parts. But software? It's just code. It's kind of invisible. So how in the world do you figure out how long it's going to take, how much it's going to cost, or even just how big it is? That's the puzzle we're tackling today.
Everything in project management, whether it's budgets or deadlines, it all hinges on one thing first: getting a handle on the size. If you don't know how big the project is, you're basically just taking a wild guess. So the very first challenge for any software team is to figure out a decent way to measure the size of what they're building before they even start.
So naturally, the earliest and, let's be honest, the most obvious answer to the how big is it question was, well, let's just count the lines of code. And that simple idea gave us our first major category of software metrics.
This whole approach is what we call a size-oriented metric. The basic idea is that the physical size of the code itself can be your starting point, your baseline. Once you have a number for the size, you can start measuring other stuff against it, like how many bugs do we have per 1,000 lines of code, or how productive is the team.
Okay, so what exactly are we counting here? The rule is actually pretty simple. You count any line of text that's actually part of the program's logic. But, and this is important, you ignore any lines that are just comments explaining things. And you totally skip any blank lines that are just there for spacing. Let's look at a quick example. Take this little piece of code. If you were to count every single line, including that comment up top and the blank space, you'd get, 13 lines? But if we use our rule, we throw out that comment line. So the official lines of code, or LOC, count here is 12. See? Super simple. And this is exactly how teams use it for planning. Imagine you're starting a new project. You think it's going to have about 10 different modules. And based on your past experience, you guess each module will be roughly 300 lines of code. You just do the quick math, and boom, you've got an estimated size of 3,000 lines of code. Now you have a number you can actually work with. And once you have that size estimate, you can start calculating other really important stuff, like productivity. This is the classic formula for it. Productivity equals KLOC, which is just a fancy way of saying thousands of lines of code, divided by effort. And that effort is usually measured in person months, which is just the amount of work one person can get done in a month. So, what's the big takeaway here? Why did LOC become so popular? Honestly, it's because it is just so easy to measure. You don't need complicated tools or a ton of analysis. You just count the lines. It's straightforward. But, and there's always a but, right? Is it really that simple? If you're just measuring length like with a ruler, are you actually getting the full story? Does that tell you anything about how complex the project is, or what value it delivers? This is where the whole LOC metric starts to show some pretty serious cracks. Yeah, the downsides are pretty big. For starters, it's totally language dependent. The same feature might take 100 lines of code in an older language like C, but only 20 lines in something more modern like Python. Same function, wildly different size. Plus, you can't use it early on because you need the code to exist first. And maybe the biggest issue, it only measures length, not what the software actually does for the user. And it completely ignores complexity. One incredibly clever, complex line of code could be worth way more than 100 simple, repetitive lines. So, because of all those problems, a totally new way of thinking started to emerge. People thought, hey, instead of measuring the code, what if we measured the functionality that the software actually gives to the user? And that shift in thinking led to something called the function point metric. Function point analysis looks at the project from the outside in, from the user's point of view. It counts things like user inputs, outputs, queries, and files. So, for example, a simple login screen might have 2 inputs, the username and password, 1 output, like a success or error message, and 1 inquiry, checking the database. It's a way of measuring the functional size of a system. And the best part? You can do this super early in the project, just from the requirements, way before a single line of code gets written. So now we've got 2 completely different ways of looking at software size. One looks at the physical code itself. The other looks at what the user can actually do with it. Let's put them side by side and see how they stack up. Honestly, this is the best way to think about it. Lines of code is like a ruler. It just measures the length of what you've built. Function point, on the other hand, is like the architect's blueprint. It measures the scope and features of what the final building will do, and it doesn't really care what materials you use to build it.
This table really nails the key differences. Function point starts from the project specifications, while LOC is really just guessing based on past projects. FP is language independent, which is a massive win, while LOC is totally tied to a specific language. But here's the most important part. Function point is user-oriented. It cares about what the user gets. LOC is design-oriented. It only cares about the code itself.
Okay, so after looking at all the pros and cons, the big question is, which one's better? Which measuring stick should you actually use? And the answer, which probably isn't a huge surprise, is it depends. There's no magic bullet here. LOC can still be really useful for tracking things on a project that uses one consistent programming language, but Function Point is way better for estimating early on and for comparing different projects built with different tech. Honestly, the best teams usually use a mix of metrics to get the full picture.
And that kind of leads us to a final thought for you. In a world where AI is writing more and more of our code, and low-code platforms let us build huge applications with very few lines, are both of these metrics kind of becoming obsolete? What are we going to use to measure software in the future when the whole idea of writing code is changing right in front of us? Something to think about.